Hello, students. We have discussed how to construct a portfolio and how to calculate the expected return of a portfolio. We're going to continue to discuss how to calculate the variance of a portfolio and the beta of a portfolio. Now, let me share my slides with you. Okay, portfolio variance. Or to be more exact, we are going to calculate the variance of returns on a portfolio. To compute the variance of a portfolio, we need to have the portfolio's covariance matrix. The covariance matrix shows the covariances between the covariance between each pair of the assets in the portfolio. Of course, this covariance in the matrix could be the true value under the probability distribution, or this covariance can be estimated from a sample of time series data. Again, in the real world, we usually estimate this covariance, or in this case, we usually estimate the covariance matrix using the historic data. Now, let's use an example to explain. Let's look at an example of covariance matrix. In our portfolio, we have three assets: asset A, B, and C. Then the covariance matrix of this portfolio can be shown as below. We are going to have we're going to have a matrix. We're going to have a matrix. Each asset in the portfolio is assigned to an exclusive row and an exclusive column. Or in the other word, each row or column in the matrix is labeled with an asset. Thus, an element in the matrix shows the covariance between the row asset and the column asset. In the other words, each element of the matrix tells us the covariance between the asset given at the top of each column and the asset given at the left of each column. And so each element of the matrix tells us the covariance between the asset given at the top of each column and the asset given at the left of each row. Now let's look at this matrix. So each column is labeled by the name of an asset in the portfolio. For example, this is the first column, right? First column is named by the name of the asset A, and this column asset B, and this column asset C. Also, each row is labeled by the name of an asset in the portfolio. For example, the second row is labeled as B, as B. Okay, the asset B. And then in this case, yeah, each element in the matrix shows the covariance between the column asset and the row asset. For example, yeah, I choose an element here, right? Element here. This element shows the covariance between the column asset C and the row asset C. And for this one, it shows the covariance between the column asset B and the row asset C. Okay, so in this case, yeah, we can show the covariance between any pair of asset in the portfolio in this matrix. This matrix has has two important characteristics. First of all, as we go down the diagonal of the matrix from the extreme northwest corner to the extreme southwest corner, we're looking at the covariance between the column asset and the row asset. In this case, the column asset is the same as the row asset. Okay, as we go down from the northwest, diagonally down to the southeast, then on this diagonal, we have the covariance, right? The elements on this diagonal, we have the covariance, and this covariance is between the column asset and the row asset. And in this case, the column asset is the same as the row asset. Because the column asset is the same as the row asset, then this covariance is nothing but the variance of this asset, right? For example, now let's look at one element on this diagonal here. Okay, that is element column B and row B. So here, this element shows the covariance between asset B and asset B. We already know the covariance between asset B and asset B is nothing but the variance of asset B. So now we can conclude on the diagonal of a covariance matrix, the elements show the variance of assets in the portfolio. Okay, so that is the first important characteristics. And the second one is, we can see this covariance matrix is symmetrical on the diagonal. Okay, on the diagonal. Okay, now let's look at the elements. Let's look at two elements that are symmetrical around the diagonals. For example, this one, this column, this element, that is column B and row A. Symmetrically, we can find the other one. Right? Okay, that is this element. That is column A and row B Okay, now we can see these two elements have the same value because above the diagonal we have this one. This is the covariance between the asset B and asset A, right? And now let's look at the corresponding element below the diagonal. Okay, symmetrically. Okay, now let's look at this one. This is the covariance between the asset A and asset B. They should be equal to each other. They are the same thing. Okay, so we have the second important characteristics of this covariance matrix. Okay, the pair elements symmetrically around the diagonal have the same value. The pair elements symmetrically around the diagonal have the same value. For example, now let me give you one more example. For this one, that is element column B and row C. Symmetrically, we can find the corresponding element above the diagonal. That is column C and row B. These two covariances have the same value. Okay, and now before we move on, I'd like to ask you a question. How many elements in this example? It is easy for us to count, right? Yeah, if you count, then you can see there in total there are 9 elements in this covariance matrix, or there are 9 covariances between 9 covariances in this covariance matrix. Okay. Now let's generalize the case. If we have n assets, now let's say in our portfolio we have the number of assets is n. Then how many covariance in the covariance matrix that we will have? Okay, it is easy, right? That should be n squared. Okay, yeah. In this case, we have 3 elements. We have 3 assets in the portfolio. Then in total, we have 3 squared. That is 9 covariances in the covariance matrix. If n equals 5, then how many covariances are there in the covariance matrix? That is n squared. Then that is 25, right? So that is covariance matrix. In order to calculate the variance of portfolio, we have to expand the covariance matrix. To determine the variance of a portfolio, we also need the weights of the assets in the portfolio. We add a weight to the corresponding column on the top and the corresponding row to the left. Then we can get a portfolio covariance matrix with the weights. Okay, in our example, let's use XA to show XA, XB, and XC to show the weights of asset A, asset B, and asset C in the portfolio. Then we put these weights on the top of each column correspondingly, and also we put the weights to the left of each row correspondingly. Then we have expanded covariance matrix. We call this expanded covariance matrix as portfolio covariance matrix with weights. Right now, this is the example. I put A, the weight of asset A on the top of column A, and also I put XA to the left of row A. Now we have covariance matrix with the weights. Okay. Now again, now we can see, right? Yeah, in this covariance matrix, the elements on the diagonal are the variance of assets in the portfolio. Yeah, this one, this one. This one is the variance of asset B, right? And this one is a variance of asset C. And also, yeah, we can see the two a pair of covariances symmetrically around the diagonal have the same value. For example, this one covariance between asset C and asset A. Covariance between asset C and asset A has the same value as this covariance. That is covariance between asset A and asset C. Okay, after we get the covariance matrix with the weights, then we can calculate portfolio's variance. We follow this procedure. First of all, we multiply each element in the covariance matrix by the weight on the top and then by the weight on the left. Okay, for each element, we do this. We multiply this covariance in this element by the weight on the top of the column and then by the weight to the left of the row. After we have done this, we add them up across all the cells in the matrix. Then the sum is the portfolio's variance. Now let's look at our example, right? Our three asset portfolio example. Now this is a covariance matrix, and in each element, yeah, for example, in this element, column A and row A, here we have a covariance between A and A. Okay, we multiply this covariance by the weight on the top of the column. Okay, and then by the weight to the left. Then we have XA times XA times covariance between A and A, right? And for this one, we do the same thing. In this element, in this cell, it is the covariance between asset A and asset B, right? Then we multiply this covariance by the weight on the top of the column, XA, and then by the weight to the left of the row. Then we get this one, right? XA times XB times covariance between A and B. Okay, we do the same thing for each cell or for each element, and then sum them up, Okay. So in this cell, in the cell column A and column A, we have covariance between A and A. Then it is nothing but the variance of asset A, right? And XA times XA, then that is XA squares. So we have the first term. And then for this cell, of course, yeah, in this cell, it is XB squared times variance of asset B. And in this cell, that is the variance of asset C times the weight of asset C squared, right? And then for we know the value in this cell and in this cell should be the same, right? For example, in this cell, it is covariance between B and between asset B and asset A, and then times XB times XA. And in this column, yeah, we know that is covariance between A and B times XA and XB. So this the value in these two cells should be the same. So we have 2 times XA times XB times covariance between A and B. Okay, and for these two cells, for this one, and this one, they should have the same value, right? And then we have this term, this item, and finally we look at this cell and this cell. These two cells have the same value, and when we include these two values in our sum, then we have 2 times XB times XC times covariance between B and C. Okay, so this is the example. This is the example, or this is a formula to calculate the variance of a 3-asset portfolio. But anyway, in the real world, no matter how many assets there are in our portfolio, we can follow this procedure. To calculate the variance of the portfolio. Okay. In the real world, we usually estimate the covariance matrix with historic data, and then use the estimated covariance matrix to estimate or to calculate the portfolio's variance. Now, in this slide, I show you an example. That is a 4-asset portfolio. Of course, we are going to use the Excel to do this. Okay. Now, I open this Excel file. Now you can see the Excel, right? Excel. Here, it is a covariance matrix. Right? In this covariance matrix, we have 4 assets: A, B, C, D. Okay, and this area is the covariance matrix, and of course, on the diagonals, there are variance of an asset, and in a pair of variances symmetrical around the diagonal. For two covariances, which are symmetrical around the diagonal, they have the same value, right? For this one and this one have the same value. Okay, now I put the weight on the top and to the left. Then we have a covariance matrix with the weights, or we have a expanded covariance matrix. Okay, and I think the calculation is pretty simple, right? We multiply each element by the weight on the top and then by the weight to the left, and then sum them up. I think this operation is pretty simple. I believe you can do this by yourself. This sheet shows the operation. You can do this step by step. Okay, step by step. And after you get the variance, take the square root of the variance. You can have the standard deviation. Okay. The procedure is the same. However, how to realize this procedure? you can use different method, right? Yeah, you can develop a different method. Okay. I think yeah, this is these two cells shows a method, and these two shows the other method. Okay, and this one shows the other one, and this we can put all these operations in one Excel formula. Okay, for this Excel formula, I think you can look at how this formula works by yourself. All right. Okay. So that is how to calculate the variance of a portfolio. After we get the variance of the portfolio, of course, we want to look at the beta of the portfolio, right? Yeah. When we assess the an asset, we usually look at expected return variance as well as the beta. Later on, we're going to in the next topic we're going to learn more statistics to assess the performance of a asset or a portfolio. But right now in this topic, we focus on expected return variance and the beta. Now let's look at how can we calculate the beta of a portfolio. It is relatively easy. Okay. Generally speaking, let's suppose we know the weights of a portfolio. We know the beta of each asset in the portfolio. Then we can use this formula. We can use this formula to calculate the beta of a portfolio. In a sentence, we can summarize this formula with a sentence. That is, the beta of a portfolio is a weighted average of the betas of the individual assets in the portfolio. Okay. We use the beta P to represent the beta of the portfolio, and we use Xj to represent the weight of the asset J in the portfolio. Okay. And we use beta J to present the beta of the asset J in the portfolio. And then, according to this formula, we know, first of all, we do the Xj times beta J for each asset. That means for each asset, we do the weight of this asset times the beta of this asset. Right? And then we sum them up. This is a summation notation. We sum them up from J equals 1 until J equals M. In the portfolio, we have number of M assets, right? So that is how to calculate the portfolio's beta. Of course, we can use an example to explain. Okay, the same portfolio in which there are 4 assets: DTE, Coca-Cola, Intel, and KEI. We know the weights, right? We know the weights, and now we know the beta. We can estimate the betas of these assets using the historic data, right? Using the historical return data, and then for each we follow the formula. For each asset, we do weight times beta. For example, for DTE, that is weight of DTE 0.133 times the beta of DTE 4.03. For the Coca-Cola, we do the same thing. Okay, this is the weight of Coca-Cola, then times the beta of Coca-Cola. We do the same thing for all assets in the portfolio, and then sum them up. Okay, and here it is of course, yeah, in the real world, we usually use Excel, okay, or in our class, yeah, and you can use the other software, but yeah, in our class, we show how to use the Excel to do this. I think that is pretty simple, right? If you open this file, you can find there are a couple of methods to do, or there are a couple of functions, or you can develop different functions to realize this operation. Okay, so yeah, I'm not going to show this. And now, yeah, in this topic, yeah, we have learned how to calculate the expected return of a portfolio, the variance of the portfolio, and the beta of a portfolio. If we know the weights of a portfolio as well as expected return, covariance, and the beta of each, yeah, as well as we know those statistics. First one, expected return of each asset in the portfolio. Second one, the covariance between any two pair of two, the covariance between any pair of two assets in the portfolio. And the third one is the beta of each asset in the portfolio. Okay. And here it is a in-class practice. I think in this exam, yeah, I think you can do this right now. Yeah, it is a very simple portfolio. Now we can see, yeah, this portfolio is composed of two assets. The weights of the assets are as follows. One is risky asset A. Okay, it accounts for 67.77%. Okay, the other one is the risk-free asset. Yeah, risk-free asset. It accounts for 33.33%. And then, yeah, we know the statistics of these assets. Yeah, we know the expected return of of asset A and risk-free asset. We know the standard deviation of asset A, beta of asset A. And how about the standard deviation of risk-free asset? How about the standard deviation? So yeah, we know, right? We know that we should know the variance between any pairs of two assets in the portfolio. Then what is the variance between asset A and a risk-free asset? Okay. Then what is the first of all, what is the covariance between asset A and the risk-free asset? What is the variance of asset A? And then, yeah, I think let me give you a clue. All right. So we're going to have a matrix. In this matrix, we have asset A and a risk-free asset. Okay, and that is a row. That is column and the row, risk-free asset. Okay. Now let's look at the variance of asset A. What is the variance of asset A? Now we know standard deviation of asset A is 20.2%. Then the variance of asset A should be 0.020 squared. That is the variance. Okay, and then what is the variance of risk-free asset? You can think of that, right? Risk-free, that means there is no uncertainty. The return in the future or in the next period is constant. Then, in this case, what is the standard deviation? Standard deviation is 0, right? And now let's look at the covariance between asset A and the risk-free asset. No matter how the return on asset A changes, the return on risk-free asset does not change. Then in this case, what is the covariance between these two assets? Of course, it's 0, right? And then symmetrically, symmetrically around the diagonal, the cell on the below the diagonal should have the same value as the cell above the diagonal. So here it is 0. Right. So we have this covariance matrix. After we have this covariance matrix, then we put the weights on the top and to the left. So the weight of asset A is 0.6777, right? And the weight on risk-free asset, that is 0.3333. And now let's look at to the left of the row. Okay, here it is 0.6777. That is the weight of asset A, and then the weight of risk-free asset is 0.3333. Okay, now we have expanded the covariance matrix. Now I believe you would know how to calculate the variance of this portfolio. All right. Okay. That is all for this topic. Thank you.